Okay, in this video, we're going to go over AgForm's variable slope design function. Go to the Home tab under Design. We have variable slope. And you don't have a section, so it's going to ask you to create a section. Just click Yes. And then you get this menu. And they're up here in the top, you have the design type, and there are various types. We'll go through those. Type 1 is basically a planar surface in the row slope and the cross slope, just like any planar surface in the normal functions. But you have a few more capabilities available to you to change things up. But basically, it's a planar surface. So what this means is slope is uniform on the row and cross rows. Drainage is positive on both rows and cross rows, meaning that from, say, if it's falling from north to south, it's all positive drainage north to south, and if it's falling from east to west, it's all sloping east to west with no reverse slope or anything, as in others. Type 2, you'll have variable slope on the row and the cross slope, but it'll all be positive. So the row slope will vary based on the parameters you put in going downhill, and then also the cross slope will vary as you go across the field, but everything will fall in a uniform direction. Say there again, from north to south on the row and east to west on the cross slope. So it'll all be positive, but it'll be variable drainage, whereas up here in type 1, it's all uniform. So this will vary, this is uniform. Type 3, you have a planar slope, which is positive, and then you have a variable slope side to side, which will be positive. So drainage is positive on both rows and cross rows, but on the row direction, it's all consistent, and on the cross, it's variable, but positive in one direction. Type 4 is a positive in the row direction, and it's all planar and uniform, but on the cross direction, it's variable in both directions. So while you have positive slope going down the hill, and the cross slope, it can fall both ways, east and west, depending on the type of terrain that you have. Then type 5, which is typically the most that I use for just furrow irrigated fields, it's variable on the row slope and the cross direction, and it's positive in the row direction, but it goes both ways in the cross direction. And then type 6, it's variable in all directions. So this is type 6 is something that you may would use if you're just doing for work under a center pivot or something like that, where you don't really care which way it goes, because you're not going to be watering down the middle and not trying to flood it up or anything like that. So if we go back to the menu here, we'll do a type 1, and you'll see that it's so if we do, like, put in a parameter 1% slope, and then say 0.15% slope, and then on the cross slopes that can be 0.5, but it's going to be positive in both directions. So if you click on this, it'll tell you if you need to change something. So you click and nothing changed. So so this is basically a planar surface, and you can tell from the contour lines. Let me turn off these cut fill contours. Here's our existing, and then this is the design contours. So it looks just like it would if you was to do a best fit or a fixed plane design on it with these slopes. So and thing with the best fit, it'll tell you the best fit, in both directions, but you can change these in the in here to set it to where if you it'll choose what's best somewhere within this range. It won't necessarily be one or the other, but it'll choose what's there. So now if we go to a type 2, and see here we have 5% or 0.5% fall from 0, and then a 0.5% rise. But that, going by that is positive and negative slope. So you have to change these. So if you click compute, it'll tell you that you can't have the same slope direction. So we know it's wanting to fall basically to the south and east. So we'll make it rise to the north, which will be a fall to the south. And there again, if you have the wrong numbers keyed in, if you click compute, it says row slopes can't have the same sign for this type. So what we want to know, we can go 0 to 0.5%. Let's just say that we don't care if it's flat side to side, or we can have somewhere from 0% to 0.5%, but it won't go any more than 5%. So these are your limits that you're setting anytime you put these in. And so we can just click OK, click compute. Okay, let's see here. We won't fall. Had that wrong. Compute. Now then, you can see what it did. It's anytime that you give it a slope that it doesn't want, it will run you straight lines until it can curve and then back around. Also, here's something else to look at. You can see how these lines are kind of jagged. So you can go back in here. We can do the max cross slope rate, and what this does, this will smooth out those design contours so it won't look so jagged. So we can put in 0.05, and you see how it kind of smoothed those lines out. So this is positive slope in both directions, and you can see from the contours everything is falling this direction, and it's 0 here because we gave it that 0 parameter. And then once it starts curving around, it won't go any more than 0.5 fall per 100 feet. And you can see as these contours get closer, we're getting to the 0.5 fall per 100 feet. Whereas in here, they're spaced out a little bit further. So if we go back and change this. So now we can try the type 3, which is a planar surface, positive slope direction, uniform, but variable all in one direction. So we can do the same thing, and you can see how it changed it. And if we go back to the other, we were 127 yards to the acre here. If we go back on type 2, go back type 3, we're 158 yards to the acre. So it increased the yardage a little bit, but it also kind of smoothed out these contours. So whatever you're doing things, you can try the different types to see which way looks the best, regardless of what the yardage is. As long as it doesn't change it too much, try and keep it within what you're trying to achieve as far as yards per acre. So then we go into then we do type 4. And so it changed a little bit, 158, but this is type 4. If we go back to this, let's see here, it says, we have variable slope going down the row. No, it's type 5, excuse me. Type 4 is a consistent slope, uniform slope going down the row, but undulating across the road direction, meaning it has positive and negative slope. So it can fall back both ways. In this case, it doesn't do that, just on the way this is laid out. But you could have some parts of this, falling back this direction. Everything is still, going to the east, with a slight fall to the south in these contours here. But if you had it undulating both directions, it could kind of they would turn back on themselves to where water wouldn't all go in this direction. So now we come to the type 5. And here we can give it different parameters. So we know we want it to go no more than 1% fall per 100 feet and at least a 1/10.5 fall per 100 feet. And we don't care if it goes 0.5% in either direction. So it, for a cross slope. The main thing we're concerned with is the slope down the road that we're going to be watering, and what it does side to side. We don't care as long as it doesn't get too much, and we're restricting it by putting in these numbers here. So we click compute, and you can see how the contours, this one is 105 yards to the acre, so this is the lowest yardage design so far. And you can see how it follows more closely with the natural slope of the land. By the design contours are laid on top of the existing contours, and then it starts changing a little bit in here, and it changes more in here because we've got this kind of notch sticking up here that is not falling within the way that we want, because you've actually got slope going backwards here. If we turn on our cut fill contours, turn off these existing, and you can see that we're filling up in here, cutting this out, and all this is mostly neutral because this, if you remember, this is where the design contours were pretty much following the existing contours. So anytime the design contours don't follow the existing contours, then you'll start getting into a cut or a fill. But where they follow them real closely, you're going to find that there's hardly no cut or no fill. So if we go back to, we'll work our way backwards, we'll do a type 4. And we're back up to 140 yards to the acre. And let's see here. You can see they follow pretty close down in here until we get up in here. So you've got this knot up in here that doesn't go the way that we want it to go. So that's where most of your cut is going to be. And then there's a ridge up in here. And this ridge here is being cut to fill up this low spot back here. So if we turn on this, we'll see that we have a lower area here than what we do here. So we're wanting a positive slope from here all the way to here. So the dirt on this ridge here is being used to fill this up. So if we go back to a type 3, so you've got to have the same sign. Rise, and this is, we'll make that 0. And so now we're 158 yards to the acre. Type 2, which is variable on the row and the cross slope, but it's all positive in both directions. See, not much change, but you see that these kind of straightened out here. And then we'll go back to type 1. And see, now it's like a planar surface, and we're at 235 yards to the acre. So by using these different design types, you can change how the field looks to make it work the way you want it to go. So, and here you have the direction of your primary slope, and typically you'll find this direction by doing a best fit first, or looking at the existing contours. You kind of have an idea which way the field is sloping. Here, these are your minimum and maximum slopes. This is for the row, so that what this tells us is we don't want it to fall any more than 1 foot fall per 100 feet. But we want it to fall at least a 1/10.5 fall per 100 feet. Here on your cross slope, in this particular case, we have 0% because we want it all fall, one direction, positive to the south. And then we have 0.5%, which it'll fall no more than that. So if we go back to a type 5, and we put in 0.5 here, calculate it. So which, see, that was the cheapest one, 105 yards to the acre. And this will work for a furrow irrigation scenario because we don't care what it's doing side to side as long as we have the slope that we want going down the middle. So in this case, it'll fall no more than 1 foot fall per 100 feet. It will fall at least 1/10 down the middle, and it can go at least up to 5/10 fall side to side, north or south. So we don't care because we're going to have a row that is going to contain the water. And in my experience, in doing this for years, typically what I try to do, whatever this slope is right here, I try to keep it somewhere between 3 to 5 times whatever this minimum slope is. So in this case, we've got 1/10 fall, and we have 5/10 fall. So, 3 times is 0.15 times 3 would be 0.45. So this would be 0.45. 4 times would be, this would be a 6/10. Typically try not to go over half a foot. Just because one thing, if you get into NRCS specs or design specs for government programs, you can't have more than a 0.5% slope in any direction. So we kind of use this as a maximum, but there are times where, depending on the field that you're working on, you can increase this to more, which will, if you have a lot of side slope, you can increase this, which will allow you to increase this. So let's just say if we change this to 0.25% fall, that would, we don't really need 0.25, but we've got so much side fall in the natural lay of the field that we could change this to a 0.75, which would be 3 times more what this number would be, and it would actually decrease the yardage because we're not restricting this side slope as much by increasing this number here. So you could have 0.25 here and 0.75 in each direction here, and actually come up with less yards per acre than if you had 0.15% and 0.5%, just based on the side fall of the field when you get more rolling terrain. Also up in here, you have your grid spacings, 10 feet, 25 feet, and 50 feet. I'd use 25 feet. 10 feet, will, if you use that, the design will hug the natural slope of the ground more closely because these are grid spacings. You get into a larger field, you start doing a 10-foot spacing that makes the file size really large that you're trying to put into the machine control for land leveling on the tractor. So, and 50 feet is a little too much, especially if you got more to rolling land, because it's not going to hug the natural land closely as like a 25 or a 10. So for all around, I use 25 feet. Like to explain this, this changing this number will make these contours smooth out. I never use this or make slopes monotonic, which means monotonic makes it uniform curving, which anytime you change anything from any of these variables here, if you restrict the land from doing what it's wanting to do, it's going to increase your yardage. So, this here gives it a pretty good range for this field here of what we want to do. You see a lot of green down in here. This blue, if we flatten this number out to 1/10, you'd see a little less yardage. So if we just go 0.10, see now we're 92 yards to the acre because now we're filling less in these areas. We're not building as much slope into this as we do with a 1/10. So depending on what kind of slope you want down the middle, you want enough that for furrow irrigation based on the row length. But this is a short field. This is only 14 acres. So you can get by with a 1/10, but in some places where you have quarter mile or longer runs, you'd like to have a 1/10 or maybe even more if you can get away with it. depending on what the land will let you do. So you go through all these different types, and it will try different scenarios, what works best for you. Here you can do your import export for around the edge of the field. One little caution here on the import export. This design is basically used to try and get the least amount of yards moved. So, we're like at 92 yards to the acre here. You can add in some import export, but if you put in too much, it's not going to give you a solution, because now you've got more yards in the perimeter, building the pad or all the way around, or if that's what you want to do, whatever you want to do with this export dirt, then you actually have in the field itself. Now, you can to a certain point, but after a while, it won't give you a solution, or it'll give you a false solution over here in these. So you have to look out for that. Here you have the cut fill ratio. You can do a minimum cut fill ratio and a maximum cut fill ratio. So it'll range somewhere in between this. If you start adding, a lot of extra dirt, you can go up to a 5.0 cut fill ratio. So, that, because if you start exporting a lot of dirt, you got a lot more cut than what you have fill. So you increase this cut fill ratio to a larger number, and that'll help take care of that. You can set the maximum cut, maximum fill, which I typically don't do that. There are other ways to do that. You have this node cut fill file that will restrict cutting and filling in certain areas of the field, like over a pipeline, or if you're trying to build up the bottom of a field a certain amount because of backwater, you can use this node cut fill file, and that's something that I'll get into in a later video. But so you have a lot more choices with variable slope than you do with a planar surface. So if we just went and did a best fit on this, that's what a best fit will look like. And here are slopes, 0.97 by 238 to the east. So, and then from a planar surface, fixed slope, we can change these to round them up to 0.1, maybe take this, back it off to a 0.2. And so it increases your yardage. Now we're at 239 yards to the acre on a planar surface. So, if you were trying to do a rice field, you just take out this side fall, and we can back this up to 0.15. So now you're at 323 yards to the acre. So you're doing all your cutting here and bringing all your fill down here, because this is where it was sloping down this direction. So that just shows you the difference between the cut fill of a variable slope and a planar slope. So there are other things you can do with variable slope, and so you have a lot more options available to you. And like I said, in this node cut fill file, which can be a little hard to grasp sometimes, but once you learn to do it, you can it really helps you with trying to not work over pipelines and keep water from backing up in the field in different areas. So anyway, that's that for a variable slope design.